Hello and welcome to Buildings of Tomorrow. My name is John Lester, and in this episode we're talking about the best practices within the industry when we talk about hydronic design. I'm joined in the studio today by Chris Kopp, who's an expert in HVAC and hydronic theory. Chris, thank you for joining me.
My pleasure. Thank you for having me here, John.
My pleasure as well. We've talked a lot about hydronic systems, the different components and the different designs. Is there a best practice within the industry that really utilize all of these options to make the best solution possible?
Yeah, I think we clearly see a trend that goes towards variable flow systems all the way through, utilizing, as we discussed before, throttling circuits and injection circuits with two-way valves to really ensure that we have variable flow from the production all the way to the consumers and only run as much water as needed throughout the building at any given time. Of course, there are owners of buildings or operator of buildings that take that step even a little bit further, go a little bit to the extreme, you could say, and say, we want to have variable flow all the way across the system with one pump, if possible, and really only work with throttling circuits throughout the building, which is kind of a radical approach, but when you think about it, if you only move as much water as you need, if you don't have a lot of pumps in series to each other, you have a very efficient and a very energy efficient system.
Okay, so we see people within industry now really taking the theory to the extreme and only doing variable flow and relying on the fact that this variable flow, and the system around it will be able to make the changes required to deliver the energy it looks.
Mm-hmm. Absolutely.
And if this approach to design works well, what does this enable these people in the industry to achieve?
It really allows them to run their buildings in an overall very energy efficient way. But it also has some things that need to be considered, right? You cannot go and just select common parts without further thinking. You really have to maybe be a little bit more careful when you design your system. For example, you have to be more critical by selecting the right heat exchanger with the right temperature spread, maybe making not compromises on it and pay a little bit more so they don't have a lot of resistance. And these are all things that then have to be taken into account. But from talking to building owners and operators like that, they tell me it's absolutely worth the effort to go this way and do it in this way, to spend a little bit more upfront, because over the runtime or the lifetime of this building, maybe 10, 15 years, it pays off much, much more than what they have to invest upfront. But it's not so easy, because I also hear that they say, this is a simple approach, but it's kind of new, novel, and a lot of people in the industry, be it people that plan buildings, be it people that build the hydronic system parts, for them it's brand new and they're kind of hesitant to say, let's do it this way. And sometimes they really have to force them to do it the way they want it, because it's new and people say, yeah, we have done it always in a different way. Why should we change now? We know it works. But they are very convinced that this is the way to go. And I think we also see that across the industry, the move towards variable flow systems is here, also supported by pressure-independent control valves, by valves that measure the energy and add some smarts to it. That goes clearly in that direction. And I'm glad that people out there taking it a little bit to the extreme, because I'm convinced that only this way we can make this change happen. Because we all know the building technology industry and also the HVAC industry is not the industry of the fast-moving early adopters.
Yeah.
You know.
Okay, so if they're able to invest this time and effort in the design, they take this variable flow approach across the entire system. They find people within the industry to deliver and to commission and enable this. I could imagine if they get this part of the building working perfectly, that this would enable them to achieve other things with other parts of the control system in the building.
Absolutely. As we mentioned before, the proper hydronic system setup is like kind of the foundation of a well-functioning and well-controllable HVAC system. So if we do that right, if we have the right consumer circuit, variable flow everywhere, we can then build on top of that with proven building automation functions, which there is a whole set available that works well, and then can really achieve demand-based control between the production, across the distribution, all the way out to the consumers. And I think this is kind of the top goal, is really to do demand-based control, only deliver what's needed at any given time. And again, the foundation to achieve that is a proper set-up hydronic system.
Okay, perfect. So we have people in the industry who are taking this upon themselves, who are making this happen, and we really see the benefits after it's designed and delivered and the operation of the building has started.
Yeah, absolutely. And I fully support that. You know, there are things we have to change and we have to talk about that. The more we and other people talk about that, the more it becomes ingrained in people's mind. And with that, we will be able to make this shift within the industry towards this variable flow approach.
So it's all about variable flow.
Absolutely.
I love it. Thank you very much for your time.
Thank you, John. My pleasure.
And thank you all for joining us on Buildings of Tomorrow. Please like, share, and comment on this episode, and also subscribe to us here on this channel. I look forward to seeing you again soon.